Hey everyone, so in this video I'm going to go over synthetic division. So the first problem that I have here, I want to point out a few things. You can only use synthetic division when you are dividing by something that's linear. This is linear because it's r to the first plus a number. It can only be r plus a number, and usually x plus a number. In this case they're using the letter r, but the letter has to be to the first power and the coefficient in front has to be 1. That's the only time that you can use synthetic division. It's very good to use synthetic division because it's quick and easy, but that is the one condition. So the first step is to set what you're dividing by equal to 0 so that you know what to put inside the box here. Okay, so it's -7 in this case. Then you're going to take your coefficients. Your coefficients are 1, 10, and 13. And I'm going to go ahead and start my synthetic division. The next step would be to drop down the 1 and multiply. -7 times 1 is -7. Add, you'll get 3. Then you're going to multiply. -7 times 3 is -21. And then you're going to add, and you'll end up getting a positive, actually a -8. Okay, that's your remainder. Whatever gets left last is your remainder. Now to get your answer, you will always, first off, these numbers here are your new coefficients, 1 and 3, and this is your remainder of -8. When you divide, you want to keep the letters, of course. You're always going to go down by a power of 1. So I started with r squared, so I'm going to have 1r, because that's a power of 1, because I'm going down by 1, plus 3, and then my remainder is here, and I'm going to divide that by r plus 7, because I could no longer go anymore. I don't need this 1, so I'm just going to cover it with my box when I do my answer. So that's my answer. Another thing to keep in mind when you do synthetic division is that you cannot skip powers. So if you do have a power that's being skipped over, you want to put a placeholder in it, which is going to be 0. In this case, for this example, you should see that you want to go from a power of 4 to a power of 2 to a power of 1. The problem is you're missing the power of 3. When you're missing a power, you just put that power in there. So same deal, I'm going to set this equal to 0, solve for x, and this is what's going to go inside, I call it my flower pot. And now I'm going to pull my coefficients. So 1 is the first one, then 0 is there to represent x cubed, -10, -2, and +4. I'm going to now drop down my 1 and multiply -3 times 1 to get -3. Add to get -3. -3 times -3 is a +9. Add to get -1. -3 times a -1 is a +3. Add, you get a +1. And then -3 times 1, you multiply that, you get -3. And you add and you get a remainder of 1. Okay, so now, like I said before, to get your answer, you always go down by a power than what you started with. This is a power of 4. So therefore, I'm going to go down by 1 power, making this x to the third. Minus 3x squared minus x plus 1. I'm going to add that remainder of 1 and divide it by x plus 3. And there you go. Okay, so now the cool thing that you can do right now is you can actually check your answer by utilizing the remainder theorem. So if you notice up here you solved for x already and got -3. So what you can do to check yourself is plug in -3 for every x value. So -3 to the fourth minus 10 times -3 squared minus 2 times -3 plus 4. As long as you put in the correct parentheses and the correct exponents, you will end up getting that 1 value which matches the remainder, and that's the remainder theorem. If you plug in that value opposite of the sign that is here, you end up getting the remainder, and there's your check. Alright, so the last trick that could happen with synthetic division is that the powers are out of order. You always want your polynomial, your divisor, and your dividend to be in descending power order. So if you look at my dividend, this guy here, he's not in power order. So I'm going to rearrange him so that he is. So x to the fourth, x to the cubed, minus x minus 1. This is fine. It is in power order. The other thing I notice here is that I'm missing x squared. So it'll be x to the fourth, x cubed, plus 0x squared minus x minus 1. Alright, so now that I fixed all that stuff, I put my powers in order, I put in that missing power, which was 0, I can go ahead and synthetically divide. So I'm going to set this equal to 0 and solve for x, and that's going to go inside my flower pot. I'm now going to pull my coefficients, so I have a coefficient of 1, another 1, a 0, a negative 1, another negative 1. Draw my line. I'm going to drop down 1 and do 2 times 1, which is 2. Add, I get 3. 2 times 3 is 6. Add, I get 6. 2 times 6 is 12. Add, I'll get 11. And 2 times 11 is 22. Add, you'll get 21 as a remainder. Again, I'm going to go down by a power of 1 to get my final answer. So I started with x to the 4th. Okay, so I'm going to go down from x cubed plus 3x squared plus 6x plus 11. I'm going to add that remainder of 21 and divide only that piece by my divisor. And like I said before, if you want to check your answer, plug in 2 into here. If I plug in 2 into here, so I get 2 to the 4th minus 2 plus 2 to the 3rd minus 1, you actually end up getting 21 as your check, and that matches the remainder that you got below. Alright, so I hope this helped you with synthetic division. I'll see you guys soon.